Hey everybody, this is 11I Energy Graphs for Systems. It says at time t equals 0, the card is released in the spring. Whoops, hold on, I'm missing a page here. Let's start here. Same picture, but a card of mass m with frictionless bearings, so no friction, and very light wheels, so no rotational inertia, compresses a spring of force constant k, a distance x from its equilibrium length. The cart and spring are on a table of height h. Suppose that E represents an amount of energy, so that E equals mgh. So in other words, we have an amount of potential energy, gravitational potential energy equal to E, and 2E equals 1/2 kx squared. So we have 2E stored in the spring and E stored in our gravity because we're up on the table there. So now we get to this page right here. It says at time t equals 0, the card is released, so that is right here, t0, and then the spring begins to expand. At t1, the spring returns to its natural length, and it leaves the table at the same time, so t1's right here. At t2, it lands on the floor, so t2 is that spot right there. It says at t3, it reaches the bottom of the slope, so that's t3, and at t4, it comes to rest momentarily at the top of the slope here on the other side. So released, t0, edge of the table, t1, lands, t2, begins to go up the slope at t3, stops at t4. So next part here, it says, one of the graphs shown represents the mechanical energy of the cart Earth system as a function of time, and the other represents the mechanical energy of the cart spring system. So which one represents the cart Earth system? So if it's the cart Earth system, then there is no spring contained in there. So the spring is going to do the work. And that's at the very beginning. So this one right here shows the spring doing work. So graph B must be the cart spring system there. So, the cart Earth system must be graph B there. If you look at this too, let's go ahead and talk about it so we can understand it a bit more. If this is the cart Earth system, then right here the spring is an outside force doing work, giving energy to the system. Here is where we are falling, and our energy doesn't change because we're simply changing it from potential to kinetic because the Earth's in the system. Here's when we hit the ground. So some outside force must have done negative work on us and taken away energy. It was the normal force did that. And then here we're going on the flat surface, so nothing's happening. And then here we're going up the ramp, but now we're just changing back from kinetic into gravitational potential, and that's why it doesn't change. Remember, to talk about gravitational potential, you need the Earth in the system. So over here, this is the cart spring system. So here, nothing's changing because we're just changing from elastic potential to kinetic. Here's where we're falling. So since the Earth isn't in the system, an outside force, gravity, does work on the system and increases our energy. Here we lose energy due to the normal force again, doing negative work. Here's the flat ramp where nothing's being done again, or the flat part of the table. And then here we lose energy because gravity is pulling on us and slowing us down. Again, the Earth is not in this system, and so it's an outside force doing negative work. All right, I think talking about that in more detail than they asked will help us do this part right here. So they want us to do two graphs. This first graph here is going to be the energy of just the cart here. When we go to do this, the spring is going to do outside work, and so it is going to increase our energy to 2E there. So it goes up to 2E, and why is it parabolic? Because we're accelerating as the spring pushes on us there. Here's where we begin to fall. If the system is just the cart, then gravity is an outside force, and it will also do outside work and cause us to gain energy, an amount of E. So that is now our total energy is up to 3E. Now, the normal force is when we hit the ground. That's an outside force that will take away energy. So now we're back down to just the 2E. This 2E remains because that was horizontal energy, basically, that the spring gave us. When we go sideways on the level floor, nothing happens. And then gravity is an outside force that will do work on us and negative work and take away our energy there. So that is what the graph should look like. And again, they're curved because since we're accelerating in each of these cases, we'll have a parabolic curve there. Now we're going to do the cart spring earth system here. So in the beginning, we've got the spring energy of 2e and the gravitational potential energy. So that doesn't change at all as the spring uncompresses. Then we begin to fall and it still doesn't change. Here we just had elastic becoming kinetic. Here we just had gravitational becoming kinetic, but the total amount doesn't change. But here at T2 is when the normal force gets involved again and does some outside work. And then rolling along the level floor, no work is done by anything. And then as we roll up the ramp, that remains level because since the Earth is in the system, we're just converting from kinetic to gravitational potential energy. So it says the ramp is much longer than showed. Does the cart stop at, below, at, or above point P? So let's say the ramp, is not like this, but something like this. Where will we go? Well, we'll actually go to the exact same height there. And the reason why is we still have the same amount of energy. We have 2e worth of energy no matter what. And that's going to be turned totally into gravitational. So that's going to become mass times gravity times height. The mass is fixed, gravity's fixed, so that height is fixed as well. The only thing that will change then is how long it takes you to get up there or how much sideways distance you have to travel, but the height will be the same in both cases.